Okay, so the spring compression takes 0.42 seconds. Determine the average force the spring exerts on the block. Now, there's two ways to do this. Way number one is find the acceleration. Acceleration will be change in velocity over time, right? And the velocity you got from that previous part, right? This is the number that's between 4 and 5, right? That you calculate from the other part. Okay, and then divide by the time, that's the time, right? And then F equals ma. And this will be an average force. It actually is more to begin with and less at the end. But there's our average force, right? That's one way to do it. The other way to do it is to go force times time is mass delta V. Okay, now I really don't know what to do about this. So time is 0.42. This is the mass of the block. The delta V is the thing you calculated in part A double I. A double I, the second part of part A, right? Okay, is what A, I, okay, is this velocity, okay? Now, here's the thing. I think you shouldn't round that number. And if you don't round it, you get a different answer with two sig figs than you do if you do round it to the two places that they do in the mark scheme. So, I don't know what to do with that. I don't know whether to tell you to do the wrong thing to get the answer in the mark scheme. Anyway. All right, so number E, you have no business knowing how to do this. That's sort of interesting. So hopefully people will come on here and look at this, okay? Ultimately, what we're going to do is the efficiency is going to be work output over work input. And we know the output. The output is that the spring gains 670 joules of elastic potential energy, right? Elastic. The work input is interesting, right? So we got to figure that out. Ultimately, we're going to figure out power from the electricity, right? So it's going to be work is power times time, okay? And in this case, power is I times V. So I, the current, times V, the voltage, times the time. If okay? So this is your voltage. This is your current. It's in amperes, but we don't call it amperage. We call it current, okay? Okay, so I is our current. So put the 6.8 in for I, the 120 for V, right? You don't know this yet. Maybe you do already, I don't know. And then 1.5 is your time. So this will give you the input, okay? And it's going to be a lot more than the 670, right? So divide this by this and get a number. You can either express it as a percent or a pure number, okay? Okay, so then F. F says on a particular day, the ice blocks experience a frictional force because of the section of the ramp A to B is not cleaned properly. Now it's a very low coefficient, but it's not 0, right? Okay. The length of AB is 2 meters. So here's this, ramp here, right? So it's going to go whoosh, and then it's going to go like that, right? Here's A, B, C, right? And this is 1.2 meters, right? So understand that on one side you've got 670 joules available, right? And then the question is, how much work does it take to slide across this ramp and go up the ramp, right? Okay, so compare that, right? If it takes more work to slide across here and go up the ramp, it's not going to make it if it takes more than 670 joules. And if it takes less than 670 joules, then it will make it, right? So how do you figure out the work? Okay, the work to slide across there. Well, this is 2 meters long, right? Okay, so figure out the force of friction, right? The force of friction will be what, mu times m times g, right? Mass is 55, g is 9.81, mu is this number here, right? Okay. Figure out the force times distance, right? So the work is force times distance, and the distance is 2 meters, right? So now you got the force. The force is the force of friction, right? Okay, and then compare work plus the potential energy, right? And of course, the potential energy climbing that thing is mgh, right? Okay, so compare that work, which is the force of friction times 2, plus the potential energy, right? Compare that number to this number. If this is more work than the energy you have, it won't make it. If it's less, it will. Happy hunting.